4, Module 2, Session 5, and this lesson is called Comparing Subtraction Strategies. For this lesson, you are going to need a pencil, and you will need your student book and eventually your home connection book, okay? All right, so in this lesson, we're going to think about what strategies work most efficiently for different kinds of number combinations. Yes, you have seen this slide before, so for your homework tonight, you are going to have to talk about what strategy you used, but I'm just going to recap here. So there's the find the difference, where you start with the smaller number, and then you jump to the higher number on the number line. There is the constant difference strategy, where you add or subtract the same number from both of the numbers to end up with the number that you are subtracting ending in a 0 or 2 zeros. And then you have the start with the ones strategy, Sherry and Ted's at the top there, and you have the standard algorithm, which we've talked about. And then there's the poem, the subtraction poem, so more on the top. No need to stop, just go ahead and subtract. So you wouldn't even need a strategy. If you have more on the floor, you do go next door and get 10 more. And if the numbers are the same, then 0 is the game. Okay, so for this, I'm going to start by teaching you how to play this game. So this is a game where you could play it with a family member, you could play it virtually with a friend. Might be a little more tricky that way, but that's all right. So you do need 3 dice for this game, but for some reason, if you didn't have 3 dice, one thing that you could do was you could simply draw a circle, and you could split it into 6 sections, and you could simply number them like this. And then you could use a pencil in the center and a paper clip and spin too, okay? So it's easily played like that if you didn't have 3 dice to play. So I do happen to have 3 dice here. So for this game, you do need 3 dice or, to spin, okay? So, and if you don't have them, like I said, you could do what I just showed you. So how you play the game is you choose a family member to play with or someone virtually. And players take turns rolling the 3 dice or spinning 3 times. So basically you're having to get a 3-digit number. And you're going to arrange the digits to form a 3-digit number that you can subtract from 1,000, okay? So after that, though, you want to take 2 more turns. So if you notice in the box over here to the right, so if I am player number 1, I'm just going to go ahead and write my name here. And I'm just going to play the game, but I'm going to pretend that I'm playing against my son, Kenny, even though he is taking a nap right now. But I do have dice. Okay. So here we go. I'm just getting my game all ready to go here. It kind of looks like Christmas over there. Anyway, so you choose a family member to play with, and you're starting, so both of you start with 1,000, and you have 1, 2, 3 chances, basically. And the goal of the game is to get closest to 0 after 3 turns, but you don't want to get in the negatives. That's like the whole thing. So we're going to kind of see how this goes here, right? So we're starting with 1,000, and I'm going to go ahead, and I'm going to go first. So I'm playing for myself, and I do happen to have 3 dice. So I have a 1, a 3, and a 5, and I'm going to go ahead and just do 135. So we're going to go with 1,000 minus 135. Wow, well, holy cow, you can't really borrow from anything, can you? So this would become a 0. This would, oh my goodness gracious, look at that. We would end up with that. So you would have 5, you would have 6, and you would have 8. So now I have 865, okay? So that would be where I ended up. So now I'm gonna go ahead and spin my dice for Kenny, or roll my dice for Kenny, sorry. He has a 5, he has a 6, and he has a 2. So I'm gonna pretend that he's gonna go 256. Now, you might be wondering, actually, why is Mrs. Sanders choosing smaller numbers than larger numbers? And I actually played this game a little while ago, and I started playing with the larger numbers, and I ended up running into a little problem. So if you think really carefully, that if you end up using larger numbers in the very beginning, you end up with 2-digit numbers at the end, and the problem is you're going to end up having to subtract a 3-digit number from a 2-digit number, which is going to end up putting you way in the negatives, and that's not good, right? So I'm trying to make the smallest numbers I can out of the 3 digits, okay? So if I was going to take 1,000 minus 256, I'm going to do the standard algorithm away again, just because that's the last thing that we basically talked about here. So 10 minus 6 is 4, 9 minus 5, whoa, is 4. Sorry about that, my friends. And 9 minus 2 is 7. Okay, so Kenny ended up with 744, and I ended up with 865. So now it's my turn again. Okay, so I have a 1, a 2, and a 4. So in this box over here, I'm going to say 865 minus, I'm going to go 241 this time. 241. Now when I'm looking at this one, I could use a strategy, but as I'm looking at it, I can see that I got more on the top, so I don't need to stop at all. I can simply go ahead and subtract. And I ended up with 624. All right, so let's see what Kenny gets when I roll for him here. 6, a 1, and a 3. Let's do 744 minus 613. And look at that. We have more on the top again, so no need to stop. 4 minus 3 is 1. 4 minus 1 is 3. 7 minus 6 equals 1. So Kenny is so much closer to 0 than I am, and it seems as though he's a little bit more daring. All right, so I'm rolling for myself now. Ooh, I have a 5, and a 6. Whoa. So I'm going to go ahead and do, for me, 624 minus 556. Oh my goodness. So I got to 68. All right, let's see where Kenny ends up here. He's got a 2, he's got a 5, and he's got a 6. So, my friends, when he was a little bit more daring a little while ago, little Kenny ran into a problem here. 131 minus 256. Yikes. I'm going to end up in the way, way, way negatives here. That is negative 125, my friends. And that means that I ended up winning the game, and he didn't because he's in the negative, but he's also 125 away from 0, going the opposite direction, and I'm 68 away from 0, okay? So that is how you play the game. So I ended up being the winner for that round. So I'd like you to try this game with someone at your house and let me know how it goes. It's actually quite a bit of fun. I'll probably play it with Gavin and Avery later on. So, all right, so that's how you play the game. So now moving on. So this is the sheet that you can use when you play. You can take a screenshot of it and write on it or whatever you want to do with that, okay? But now I want you to open up your student book to page 147. We are going to do this right now. So student book page 147. So this is called Helpful Hints. All right. Okay, so page 147, you should have a little bit of, wait, is this page 147? This is page 146. Whoopsies, I'm sorry about that. Student book page 146. I apologize, boys and girls. I'm sorry. 146. And I'm just going to the next slide so that I have a bigger screen to write on, okay? So Jack has to solve the problem 281 minus 266. How would you tell him to solve the problem? Tell which strategy you would use and then solve the problem. So for Jack, I think the best strategy here would be just to find the difference by adding from 266. So for this one, I'm actually going to draw a number line. And I'm going to go ahead and put 266 on this side of it, and I'm going to put 281 over here, okay? Because I think these numbers are close enough together where I could just do it that way and it would work out just fine. So if I were to go from 266, and I'm going to jump 4 spaces because I want to get to 270, because I think that would be easier for me, okay? So I have 270. Now to get from 270 to 281, I simply go 11 more because I know that from 270 to 280, that's 10. So from 270 to 281, that's 11 more. So altogether, I have gone 4 plus 11 spaces. So my answer is 15. All right, so that's how I would tell Jack to solve that problem. If I move on to the next one, Zia has to solve the problem 311 minus 287. How would you tell her to solve the problem, and tell which strategy you would use then? Okay, so 311 minus 287. I probably would not use the standard algorithm for this one, just because there's a lot of regrouping that goes on. Kind of like in that game that I was playing a little while ago, there was a lot of regrouping in that too, so I probably should not have done it that way. And the reason why I did that was to show you that sometimes there are so many steps that you take to solve a problem, when if you use one of these strategies instead, you're actually saving yourself a lot of time and a lot of steps, I guess. So what I would do if I were Jack is I would do the constant difference strategy for this one, and I would go ahead and I would add 13 to each one of these. And the reason why I would add 13 is because that will bring my 287 to a nice even 300. Okay, so 311 will end up being 324, and 287 is going to end up being 300. Now, when I'm looking at my subtraction problem now, this is looking pretty nice. So I can simply just go, oh, 324 minus 300, well, that's 24. And that is how I would tell Zia to solve this problem. So the answer for this one is 24. Okay, and then moving on to the next one, Randy has to solve the problem 358 minus 247. He says it is easy to use the standard algorithm for this problem. Do you agree or do you disagree? Let me see here. 358 minus 247. I absolutely do agree with Randy, and that is because I have more on the top, so I don't need to stop. I can go right ahead and just subtract. 8 minus 7 equals 1, 5 minus 4 equals 1, and 3 minus 2 equals 1. And I end up with 111. Yes, I do agree with Randy because there is no regrouping. Please write this down in your book as I'm writing it in mine. All right. And then you will obviously, like we've been doing in the past, put this into Seesaw just so I can see that you're doing this with me, okay? So page 146. My bad on those typos, I'm so sorry. Okay, so for number 4, we have Lonnie, and Lonnie has to solve the problem 412 minus 259. She says it is easy to use the standard algorithm for this problem. Do you agree or disagree, and why? Okay, so, 412 minus 259. I am not going to agree with Lonnie on this one. I don't. And the reason why is because there's way too much regrouping going on. And so I think it would be easier to use the constant difference strategy. And what I would do is I would add 41 to each of these, because then that way it'll bring my 259 to that 300. And if I add 41 to 412, it's going to give me 453. And when I'm looking at that, it's so much easier to subtract 453 minus 300. So I always, and I've been bringing this up a lot, I always think of fractions when I do this, because it is whatever I do to the top number, I do to the bottom, and it's the same idea there. So I would end up with 153 for this one. So I would use, so my answer would be no, because you have to regroup. More than once. And when you have to regroup more than once, like I was saying a little bit ago, you're taking so much time out to do that, like I did when I was doing that game, where I didn't need to do that. I could have added 41, I think, to one of them, and it would have gotten me to an easier number. But like I said, I wanted to show you that I'm taking so much time to figure it out when I could have used one of these strategies instead, okay? And then for number 5, it says, put these numbers in order from least to greatest. Use relational symbols greater than, less than, or equal to. So as I'm looking at these numbers here, notice that they all start in a 6. So, okay, well, moving on. Ooh, this one has a 2, this one has a 2, this has got a 9, and this has got a 9. So if I'm going from least to greatest, it's definitely going to be either this guy or this guy. Okay, so they both have 629, 629. Ooh, now I look at that next number. So that number right there, this guy is going to go over here because it is the smallest number. So I'm going to end up with 629,478 is less than. Now this guy is going to go over here because that was the other one. 629,874. Okay, now when I look at these other two over here, they both have 692, 692. But again, they both have a 4 and an 8 right here. And so this one's going to go over here. So this 629,874 is less than 692,487, which is less than 692,847. Okay, so there you have it. 629,478 is less than 629,874, which is less than 692,487, which is less than 692,847. All right. So there is that. All right, so this brings me to the last part. So this is the last part. So this is your homework, and I know that it's 2 pages, but here's the deal. With any kind of math, if this should not take you longer than 20 minutes, and if it does, I want you to go ahead and set a timer, and I want you to just stop and submit it wherever you stopped, and just have mom or dad sign it and say, this is how long it took them, okay? But I mean, if it does end up taking you longer too, if you want to finish it, by all means, please go ahead and do so. But I don't want you spending more time than you need to on this, okay? I am going to go over the answers next time anyway, so don't worry about that. But yes, just no more than 20 minutes and have, unless you want to go farther, but have mom or dad just sign it and say, I got frustrated or whatever it happens to be, whatever's the case, okay? So your homework is Home Connection book pages 79 and 80 for tonight, okay? And then find someone to play that game with. It's a lot of fun, and I had a lot of fun with it, so I think you will too. All right, boys and girls, have a great rest of your day, and I will talk to you tomorrow.